How's everyone doing? Great. And everyone enjoying build so far? No major complaints, no long lines or anything? So this session, we're going to focus on advanced Windows Azure Infrastructure as Service. So the big question might be, what exactly is advanced about spinning up a VM? What I'm going to focus on, I'm going to show you, really try to focus on two key things. The first is automation, how to do things that normally takes you a long time to do once, really quickly, multiple times. And the other thing I'm going to try to do is show you some of the more advanced things you can do from an availability and scale perspective. So before I get started too much, how many of you have saw Mark Rusinovich's intro to Windows Azure VMs talk? Or okay, so pretty much, sheesh, okay, sorry about that. So pretty much no one in here has absolutely not a complete and total noob on VMs, because I'm not going to spend a whole lot of time doing intros. So I'm going to really focus on these three things. We're going to talk a lot about automation, so using Service Management API, maybe PowerShell, the cross-platform command line interface. I'm going to walk you through using the capture feature to do some creative things with virtual machine libraries and creating images. And finally, I'm going to show you how you can use some custom probes for HTTP and TCP to increase your availability for your applications. So the first thing I'm going to focus on is automation. This is going to be Service Management API. How many of you have actually ever used a Service Management API in Windows Azure? Cool. How many of you want to someday? All right, so decent crowd. It's pretty low-level stuff. Our Service Management API is not simple. It's pretty bizarre because it's all XML too. No one uses that anymore. So just to get started on the Service Management API, it is REST-based, so you'll be using post, put, get, delete, all the basic HTTP operations to perform operations on entities in Windows Azure. Authentication is using a certificate. You put an X509 certificate in Windows Azure in your subscription, you put it on your machine, you pass it in the header, and everyone's happy. You don't have those cert, you don't get it into your subscription. The other thing that's interesting about our management API is majority of the Service Management API calls are all async. So you never call and do anything and immediately know what happened. You don't call new Azure VM and you get a virtual machine. You get a GUID that you can then take the GUID and go ask again another API, hey, what happened with this last request? So it's a polling architecture. You tell the Service Management API to do something, and then you check back later to see if it actually happened and hope for the best. Finally, it's versioned. As we add new functionality to the Service Management API, we don't want to break existing clients. So you do have to know which version of the API that you're working with. And of course, this is all documented through MSDN. So if you want a specific piece of functionality, you just need to know which version of the API supports it. A little real quick glossary. If you use things in the Windows Azure portal, you might be familiar with cloud services or virtual machines. Those are not the same names in the Service Management API. Cloud service in Service Management API is a hosted service. That's what it used to be called before the June release, and we renamed it, but their API still exists with the old name. Virtual machine in the Service Management API is persistent VM role, not to be confused with the old VM role, which is not persistent, and totally different, but they're very similar in ways as well. So as long as you remember those two things and can translate that to what you see in the portal, things will make sense to you. So as we dig into the Service Management API, it really makes sense to understand the architecture, how a virtual machine is structured in Windows Azure, because it's really just a VHD on a virtual machine, and Azure, the REST API, is actually stores a bunch of metadata that maps to it. So what does that metadata actually look like? Well, if you saw the intro talk, you know that all virtual machines are contained inside of a cloud service or a hosted service. A cloud service is a container for all virtual machines, whether it's 1 or 50. Well, the cloud service determines also which data center the virtual machine is in. So if you look at the properties of the virtual machine or the hosted service, you'll see that it has a service name, which is the public URL, your public IP address of your virtual machines. And it also has an affinity group or a location, either one. Whenever you use an affinity group has a location property and a location has a location property, and all that really does is it says it's going to be in the West US data center or the East Asia or whatever. It tells you which data center the cloud service is going to be in. And since virtual machines are built on the same service model that web role and worker roles are built on, we have a deployment slot. So we have production and staging slots even with virtual machines. So interestingly enough, virtual machines can only work with the production slot. The staging slot is unused. So the deployment is the next entity down that you'll need to know about if you want to do automation with PowerShell or the service management API. So the deployment for VMs at least is always going to be the production slot. It'll have a deployment name, which is really just a tag that you can pretty much specify whatever and use it, for your reporting if you want. It has a role list. A role list is a collection of all the virtual machines within the deployment. So each role in the role list is itself an actual persistent VM. And persistent VM role is the metadata that is represented of a virtual machine itself. So persistent VM has a role name, which is also the machine name. It has a role type, which is always going to be persistent VM role in the API. So, literally, you hard-code it as an attribute. It's pretty straightforward. And configuration sets. Configuration sets is a networking configuration for the VM, and it can have a Windows or a Linux provisioning configuration set. And obviously, the configuration set, you're only ever going to have it in that entity whenever you're on the initial boot of the VM. Anytime you ever see this entity later, it's not going to have it because it's only part of provisioning. The OS virtual hard disk is the metadata that explains whether you're booting off of an existing image or you're booting off a VHD that you uploaded to your storage account. Same thing with data disks and the role size. Interestingly enough, deployment also has DNS server. This means that at the deployment level, whenever you're deploying your virtual machines inside of a cloud service, you can actually tell them what DNS server to use. You can put the DNS server actually in the virtual network configuration if you want, but you can also deploy it, configure it at the deployment level whenever you're initially specifying deploying VMs. And finally, this is one thing that always that confuses people whenever they're deploying virtual machines in hybrid networks with virtual networking, is virtual network is actually at the deployment level, not at the virtual machine level. So whenever I create this deployment, I'll have a bunch of virtual machines in it. I could potentially have a bunch of virtual machines, and the deployment is actually, or the virtual network is actually at the deployment level. So all those machines that are inside of it all have the same network settings. So let's dig a little bit deeper into the networking configuration. So the networking configuration actually on the virtual machine is pretty simple. There's really only two properties you can have. The input endpoints, which is the load balancer, all your configuration, your inbound ports, and your load balancing settings, and subnet names. Subnet names sounds like it's really useful. It sounds like I assign it to 2 or 3 subnets, and maybe I get 2 or 3 NIC cards in my virtual machine. That would actually be really creative and very useful, and that is not the case. Whenever you get subnet names, what that really means is if you have 2 subnets assigned to a VM, whenever it boots up, it'll try to allocate an IP address off one of the subnets. If all those IP addresses have already been allocated, it'll allocate for one from the other subnet. No multiple NICs, unfortunately. Input endpoint is actually the more interesting of these 2 properties. This is basically all the properties that configure your load balancer settings or your open ports to your virtual machine. It has a lot of different properties, local port, public port, that basically allow port mapping to your virtual machine. This is what allows you to host multiple virtual machines all listening on 3389 with one public IP address, because it allows you to map multiple public ports to one single private port. Provisioning configuration, like I said, there's 2 of them. There's one for Windows VMs and one for Linux. You may not have known if you've just created a virtual machine through the portal that all these options are available to you when you're creating a VM in Windows Azure. You can set the computer name and password, but you can also tell it that whenever the VM first boots up, that requires a password to be reset on the first login. It's really useful if you're provisioning virtual machines for other people. You can set a temporary password on it, have them log in, and whenever they first log in, they got to set their own password. That way, you're out of the password management business. You can also tell it to enable or disable automatic updates. So whether Windows Updates automatically patches your OS and reboots it, or whether it's completely disabled is up to you at provisioning time. You don't actually have to log in later and set it. You can also set the time zone for the OS and deploy certificates into your VM as well. And the last property, domain join, that's actually a structure. It has a lot of other properties underneath it. And what this property allows you to do is whenever you boot up the virtual machine, you can have it auto domain join. So it can automatically join your domain. And if you've ever added a machine to a domain, if you're deploying, 10, 15, 20 VMs, that is a long amount of work to manually register your VMs. You really want to be able to automate this. Linux provisioning is similar, but you can set a few different properties than you can from Windows. It doesn't obviously have the same set of capabilities, but you can set the host name, the username, and password, which is different. From Windows, you have administrator on provision, and that's it. If you want to rename administrator, you have to actually log in after the fact and change it. Linux, you literally set the username to whatever you want it to be, and a password. And you can disable SSH, and you can also deploy SSH certificates with your Linux VM. And back on the persistent VM role, outside of provisioning, we have a couple of pretty obvious entities. You have the OS virtual hard disk. This basically tells it, am I booting off of an existing VHD that you may have uploaded to your storage account, and you would set that via the media link that actually is a URL back to Windows Azure Storage. Or you could tell it to, you'll actually need it either way, but if you specify source image name is going to be the name of whatever platform image you want to boot off of, whether it's Windows Server 2012 or Server 2008, etc. And media link in that case would end up being the target where you want this OS disk to be created at. And data virtual hard disks is very similar, except it's data disks. Basically, the only difference is one's bootable and one's not. So from an API perspective, how do you actually create a virtual machine? If you needed to make a tool to automate, creating 50 virtual machines on the fly without having to go through the portal and click through or learn PowerShell, or you were making your own command line tool, your own management tool, how would you do this? In our service management API, there are basically two APIs you need to use to create a virtual machine. And it depends on the order of the virtual machines. If you've created the very first virtual machine inside of a deployment, inside of a cloud service, you have to actually create the virtual machine with the create deployment API. So how that works is there's no such thing in Windows Azure as an empty deployment. You can't have a deployment with 0 roles. The create deployment API also doesn't support passing multiple roles. So from a developer perspective, it is a little tricky to build it. You basically have to detect whether there is a deployment. If there's not, you create one and pass it the configuration of exactly one virtual machine. As soon as that one virtual machine is created, you can then use another API, which is the add role API, and add the additional roles to it. So it's a little simpler than it sounds, but it basically is, all it really ends up being is munching a bunch of XML together and posting it to our service. Updating a virtual machine, again, it's a big XML operation. You would, if you see the really long service management URL, you would basically take that URL. You need your subscription ID, your service name, and the deployment name, and of course your virtual machine name, and you would call get with that. Whenever you call get, it's going to return back all the XML for the virtual machine. You can then modify it by adding a disk or adding an endpoint and then putting it back. That's literally all there is to modifying, adding a disk or whatever to a virtual machine. There's other operations. Obviously, you can reboot your VMs. You can capture them, delete them, shut them down, restart them, etc. And you can, of course, how you log into the portal, you can actually, that exact same functionality is exposed to you. So you can literally write your own code, log into your VMs. So now that you've kind of have a vague understanding, hopefully, of all the different entities involved, let me show you, flip over and show you some code. So what I have here, I have a really simple ASP.NET application that I've written that uses the same service management API. And what I want to do, actually, let me go ahead and step through it a little bit. First thing I'll do is I'll show you how you can actually authenticate. And this authentication mechanism works pretty much with all the services in Windows Azure. The only one that's a little different, I think, is storage. But any service that you want to automate in Windows Azure, whether it's cloud services or service bus, would all work in a similar manner from a management standpoint. So the first thing I'm going to do is get my management URI. Oops. And this is the management URL that I'm going to call to against the service management interface. Basically, it's the URL with my subscription ID. From an authentication perspective, in this case, I'm using the HTTP client. Oops, sorry. I'm using HTTP client, and I'm basically loading up my management cert. I just need the thumbprint and tell it to pull out of the current user certificate store. I'm adding that to the client certificates collection and setting the version. Doing this way, the HTTP web request is almost identical. So similar code. HTTP client's a little simpler, I think. Well, once you're authenticated, oops, missed a breakpoint. Once you're authenticated, it's relatively simple to actually parse that data back out. So if I look at the XML response from this, you can see that literally I'm getting my entire quota from my subscription back. And see, that's another thing that could be very useful for companies managing multiple subscriptions across your organization. You could literally enumerate through all your subscriptions and run reports on how your quota usage is doing. So this is what I'm using to render the header. You can see that I have 100 cores available. I've only used one. So now if we actually want to see the virtual machine information, so I'm going to call a different API, and this one is basically doing a get on the list of all my roles within the deployment. So it's a little interesting because some of these APIs, instead of taking slots, they take names. In this one, it actually takes a slot, so I can literally just pass production for the slot name. So you can see, so to get all the roles from a particular hosted service, I need to specify the service name and the deployment slot, which is always going to be production with VMs at least. So I'll call get stream async to get the HTTP response. And the actual XML is pretty straightforward. I'm sorry, this is actually the service name. So the virtual machine information, I can get the IP address. This is the DIP, not the VIP. So your internal IP addresses. If you were running some really advanced application that needed to load balance virtual machines from an internal, you could literally use really small snippets of code to figure out all the IP addresses, your entire topology of your virtual machine deployment, and do custom load balancing or any other kind of algorithms based on these internal IPs. You can get the fault domain, upgrade domain, and basically all of the interesting details out of your virtual machine. A couple other things to note is you can also see your endpoints. So we have a 3389 endpoint for doing remote desktop and port 80. So right now I only have one virtual machine on this. So you can see that I have login and shut down and reboot wired up. So we could go ahead and RDP directly into this machine. Now let me show you real quick how we can actually use the same APIs to construct a virtual machine request, so you can actually create one. So on this page, I'm just going to show you the XML output here. Whenever you're creating a virtual machine, you have to have a unique cloud service name. So unique through all of Azure, so this can't be unique within the VM. But throughout all of Azure, so my build service one, hopefully it's unique. Specify the password, and a couple of other things you need. You need to know the virtual machine size, whether it's going to be small, medium, large, extra large, or the actual image name. And what I'm doing on this is actually just generating the metadata in XML. So you can see the big blob of everything that we needed to do. Password, virtual machine name, whether it's going to reset on login. Notice there currently are no endpoints and there's no data disks. So to add anything to this configuration before we create it really just includes adding the XML. So to add the data disk, I tell it that I want to create this virtual machine with an extra disk on it with 10 gigs. This can be up to a terabyte per disk. And I'm going to put it in this storage account, VM demo West 3. And you can do the same thing for the endpoints as well. So once you hit create VM, this is actually going to call out to the create deployment API, since I only have one virtual machine in this cloud service. And it's going to return back an operation ID. So if I look at my cloud service or my query string, because I actually just redirected, that is going to be a request ID that goes back into the service management API. You can literally take the service or this request ID, and there's another REST API called get operation status. Pass it the request ID, and it will give you whether it's in progress, whether it failed, or whether it succeeded. So my case, I'm lazy. I didn't make anything nice and shiny. I just made it where I hit refresh. And you can see that we're in progress. So if I go back to my virtual machine list, you can see that we're now using 2 cores out of 100. So I've actually published this exact same app. If any of you are curious enough to, if you want to take a look at the metadata in better detail, it's on vmmanager.cloudapp.net. You can go to create virtual machine. You can step through the same XML and see how it works. Feel free to create a virtual machine. We have 98 cores available, so I don't think there's a whole lot more people than that here. But if you want to create a virtual machine and play with the XML, all welcome to. What's that? Yeah, you could tweet it, but it would be dead really quick. So I wouldn't try more than 5 or 6 people now. So that's the gist of how the service management API works. There's obviously tons and tons of other stuff you can do. You can automate disks. You can automate image creation. Anything you can do through the portal, you can automate. So that's really the gist of why you would want to go at this level. So a much higher level of abstraction would be using this from a command line, from a script. So if you don't want to write your own service management library, you don't want to parse HTTP responses and figure out all the XML attributes, you can use our scripting interfaces. We have 2 of them. We have one of them based purely on Windows PowerShell, and we have one of them that is a cross-platform command line interface that works on Windows, Linux, and Mac. It's based on Node.js. So just some of the things you can do from the command line is you can automate, you can create virtual machines, you can delete virtual machines, you can add disks, endpoints, configure all your load balancing, all from the command line. And if you really are going to try to deploy anything significant in Windows Azure where you're going to have multiple deployments, this is something you really want to look into. We literally have customers today that from a single PowerShell script can spin up an entire SharePoint farm. They can spin up SQL Server, mirror it, deploy AD, deploy multiple pretty large-sized farms up in the cloud, all without ever actually logging into a virtual machine. It's literally just, type in a bunch of configuration, obviously, and hit OK, come back 5 hours later, and you have a SharePoint farm. It's really useful whenever you have this, the availability of all this capacity at your fingertips. So how you actually get started with PowerShell. It's not the trickiest thing to get started with. Obviously, the first thing you need to do is download the commandlets. You can get those from windowsazure.com. Click on the Manage link at the top, and click on Downloads. Once you download and install a PowerShell commandlets, relatively straightforward. You call import module Azure, and this will add all the Windows Azure PowerShell commandlets to your script session. Then you can call get Azure publish settings files, and this isn't nearly as cool as it sounds like it. It should sound like it's going to automatically download something. What it does is it actually pops up a web browser and takes you to the place where you can download your publishing profile. But once you download your publishing profile, the next step is actually automatic. You can import it, type in the path to it, and it configures your certificate, your subscription ID, all the stuff that, if you've ever tried the PowerShell commandlets before, all the stuff that used to be really hard is much, much simpler now. And once you're done, any of your commands against your subscription would work. Now, the cross-platform CLI tools are basically very similar, have a different command set, but very similar functionality. The first thing you need to do with them, however, is not install a product from us, it's install a product from nodejs.org. You install the Node.js runtime. Once it's installed, you drop to command line, you type in npm install azure-g, and it'll basically go down and download all of the Windows Azure Node modules. And once the Node modules are in, and this is the same on Linux or Mac or whatever you're running on, once the modules are installed, you can call Azure Account Download. It'll launch your web browser, allow you to download your profile, and Azure Account Import accomplishes the same thing. You pass it the path to your publishing profile. So how many of you have ever used PowerShell tools for Windows Azure? Oh, wow. How many of you use Node tools? Okay. All right, so I'll show you a little of both real quick. I probably need to make my font size a little bigger. So if you're getting started, and I'm going to make the assumption that you have already downloaded the command list, but if you're just now getting started, you have a Windows Azure account, you have a VM created up in the cloud, and you want to learn how to use a PowerShell commandlets, you call get Azure publish settings file. And like I said, it's going to take you to the login page so you can log in with your Windows Azure account. And it's going to pop up a prompt so I can download these publish settings files. Now to configure it, I need to call another command. And I'm using a Power GUI as editor. If you guys have never seen this, you can use PowerShell IDE as well, or ISE. Either work. And that literally will import, it'll add a certificate to your certificate store, and inside of your user profile directory, there's an XML file that has all your subscription settings configured. And one thing that's really useful about all this is if you manage multiple subscriptions, it'll persist all of them. So you could literally manage all of them from a single command line. So if you wanted to see all the subscriptions that you have available, you call get Azure subscription. Oops, actually let me filter that out a little bit. And you can filter out different properties. So in this case, I have 4 subscriptions configured for PowerShell. So the one I just imported was a subscription I made last June at TechEd. So if I want to switch to that context to work on VMs in that one, I can say select Azure subscription. Oops. And just type in subscription name. And then I can call any command that will do anything on the VMs. So I can say get Azure VM. It'll pull back the 2 VMs that we have, the second one, third one, someone built one. So all the ones that are actually provisioning in my portal. So if I wanted to reboot one, build demo source 1. This is why it's useful to understand the structure of how virtual machines are built, is anytime you're doing an operation on a virtual machine, you always have to remember that it's part of a cloud service first. So if I want to reboot this guy, I can say restart Azure VM. The first thing I need to give it is a service name, not the VM name, because you're looking for the VMs inside of a service. So I give it the service name and then the VM name. That one little command will reach out to the service management API and actually restart that machine. And you can shut it down or delete it or whatever you want it to do. And while that one's rebooting, let me pull up another instance of Power GUI. And I'm going to show you how you could do this, use PowerShell to provision a bunch of 80 joined virtual machines. So I do have a virtual network created. So I have this network, this Windows Azure Virtual Network. It's configured. It's actually connecting back to a building over in building 20 on campus. It's actually a lot more impressive when I deliver this somewhere else, because I can say, oh, it's connected way back in Redmond, but it's just right down the street. So Windows Azure is connected to this Cisco ASA 5505 under my desk in building 20. And basically, I have a domain controller there. It's just one virtual machine. It's not that big of a private cloud. It's actually an old machine, too, so it's not even that big. What I'm going to do is I'm going to provision a virtual machine that will live in the cloud and domain join to an Active Directory domain controller over the tunnel. So it's going to connect over IPsec tunnel to connect. So it's pretty straightforward to do this. Just requires a lot of typing, which thankfully they make snippets for. So the first thing you need to know to create a bunch of virtual machines from Windows Azure PowerShell, first thing you really need to know is you have to have a username and a password, a password and the image. So the image I'm going to create is based off Surge 2008 R2. I could pick any other image I wanted, though. I can say get Azure VM image, select image name, and everything you see in the Windows Azure VM gallery, you can get directly from PowerShell. So you can create any one of these from PowerShell. So I'm going to go ahead and pick Server 2008 R2, and I have a bunch of other properties here too. So I have the domain name I'm going to actually join to. So if you're deploying to an enterprise, this is all going to look very familiar to you. Yeah, your corporate domain name, and then we also need a fully qualified domain name. So in this case, fabricam.com. And you also have to have authentication. You have to have a domain user account. So whenever your machine boots up, it has to have the credentials to actually join AD. So in this case, I have the domain administrator. And I'm going to show you how to create 3 virtual machines. So I have 3 VM names here. So let me go ahead and paste in the rest of the code. So if you look at the code, I'm just like you saw in the application, I'm creating a configuration. This is basically creating an object with the virtual machine name, the instance size, and the image name, just like the XML we saw in the Service Management API demo. And I'm adding all the provisioning configuration via the add provisioning, Azure provisioning commandlet. And this is that domain object that we saw in the entity. This is specifying all the properties that can go in that. So domain, domain join, domain password, what the username is. You can actually also specify the organizational unit in Active Directory for your virtual machine to go to. So if you're a domain AD guy and you are really good with doing group policy and you apply it at the organizational level, do it, you can do that. If you're not, don't worry about it. And finally, I'm doing one more thing. I'm adding an Azure endpoint. So I'm opening up port 80 on this virtual machine. And I'm setting the subnet on which subnet it'll boot up to. So I'm going to go ahead and create 3 virtual machines here, though. You know, it's really not automation if you're only creating 1 virtual machine. So I have 3 different configurations, and now I'm going to go ahead and call the commandlet that'll actually call the API and create these. So new Azure VM actually is a commandlet that does the work of creating the deployment, creating a cloud service, and configuring the network. So I'm passing all 3 virtual machines as a parameter to new Azure VM, and I'm telling it which virtual network to boot this guy under. So this is literally how you could create a hybrid deployment over your VPN tunnel just in a few lines of code. So go ahead and hit F5. It'll provision a virtual machine, and someday when they boot up, they'll actually be domain joined. And you notice the first step it does is actually creates a cloud service. You can, from command line, you can actually create the cloud service ahead of time and then join it to an existing one. Either way. Now, if you wanted to do create a virtual machine from the cross-platform command line tools, let me show you real quick how those work. So very similar commands. First, I can do Azure account, and it'll tell me all the command options I have available for these guys. So I can say Azure account import, Azure account set, all the properties you can do from the PowerShell commandlets to manipulate your configuration, you can do from these tools. And the really nice thing is they actually all use the same configuration file. So if you import and configure your subscription in PowerShell, it's automatically set in these tools. We did that by pure accident. So I can do Azure VM list. And it's going to go, actually, you know what I did? I accidentally deleted my certificate a while ago. Let me see, Azure account import. The one complaint I'll give these guys is they don't have an autocomplete like PowerShell does. Oh, yeah, they do. Never mind. See, you learn something new every day. Account import failed. Hold on. I'll give it one more try. You can tell I'm a PowerShell guy, not so much a cross-platform command line interface guy. Maybe it updated my certificate. It did. Okay. So even though the import failed, it actually reset my certificate, and now I can see all the virtual machines that are created. So just like Get Azure VM and PowerShell showed you, you can get the same output from within the CLI tools. And of course, this is, again, cross-platform. That's the whole point. And you can do Azure VM create, pass it the image name, just like you can PowerShell. The only thing you can't do that's significantly different is you can't domain join VMs from this tools. We assume if you're on Linux, you're probably not doing a lot of enterprise domain joins, but Might be wrong, so it might be a good feature request for later. Okay, so the next thing I want to talk about is building virtual machine libraries. How many of you have actually created a virtual machine image in Windows Azure? Oh, cool. How many knew you could actually create an image in Windows Azure? Third question, if you upload a VHD, how many of you think every VHD has to be sysprepped? Oh, good. Okay, so that's one. Oh, see. No. So you don't have to sysprep every VHD. Whenever we first came out, I think there was some confusion. When do we sysprep? When not to sysprep? So how it works is, well, actually, let me explain to you this real quick. Why you'd actually want to build a virtual machine library is this is infrastructure as service. The platform is not already pre-built for you. If you're deploying applications, you actually have to install a whole bunch of stuff on it. So if you're installing, or if you're deploying an MVC4 app, simple MVC4, the first thing you have to do is go in and install IaaS, ASP.NET, install the .NET framework, enable it, MVC. That takes about an hour every time. If you need to deploy MVC a bunch of times on a bunch of virtual machines, that is a whole lot of time that you could be wasting. So configuring the virtual machine once, saving it as an image, booting off of it, saves you an hour every time you need to deploy a virtual machine. And this is just for an MVC application. There's many, many other ones. SharePoint, perfect example. SharePoint downloading the dependencies and everything that is required just to boot up a SharePoint VM, that's probably a 4-hour process. Do you really want to do 4 hours worth of installation every time someone in your office asks you for a SharePoint VM? The second piece is for installing custom agents. So if you're in some applications that don't have direct connectivity to your VM, some applications that monitor VMs require you to install an agent on them. And it's really nice that you can actually put that agent on one virtual machine, sysprep it, and then every VM you boot off of it is pre-configured to have that agent so you can monitor it remotely. How it actually works is you boot a VM off the platform image, just like I showed you before, you saw in Mark's session, everything. You then customize it, you install your agent, add a startup task, you do whatever you need to do, then you generalize it. This is where sysprep comes in. What sysprep actually does is it basically removes everything about your virtual machine except your user data that makes it unique. It gets rid of your computer name, your SID, and all kinds of other interesting things in the registry that makes a Windows machine. And before I move forward, you can also do the same thing on a Linux VM. You can capture and make a Linux agent, because we actually or a Linux image. We actually have a Linux agent that runs on our Linux VMs that whenever you can actually run a command, WAA agent, and some parameters I don't remember, that will basically make it unique or ununique and make it an image that you can then customize and reboot and boot from. Anyways, once it's generalized and shut down, has to be generalized and shut down, you then use capture. There's a little button in the portal called capture that whenever you click it on a sysprep shutdown virtual machine, will take it and save it as an image into blob storage. And then whenever you go to create a VM, in addition to all the platform images, you'll have your own image as well that you can boot off of. And every time you boot off of it, you start from the exact identical starting point. So depending on what you deploy, using images can save you tons and tons of time. So one of the things I'm going to show you how you can do capture, but I'm also going to show you how you can use a startup task. It's really surprising how few people know that you can actually go ahead and group policy and just configure a startup task to run in Windows. Whenever we first launched this, it was literally a common question throughout all of Microsoft. Hey, I got a virtual machine and I want it to boot up and do something. How do I do that? So it took us a little while to figure out that you can just go into group policy and tell it to boot up and do something. But as Windows Azure developers, we don't do that stuff. We don't know how all that stuff works. So some of the things you can do for startup tasks, just some ideas, I'm sure you can come up with 500 other ideas, is enable remote PowerShell. By default, when you boot up Windows, it's not like Linux. It's not really easy to remote into. You have to go unlock everything. It's great. It's very secure. It's also a pain in the butt if you want to remotely manage your VMs. So you can configure a startup task that every time a new virtual machine is booted off of your image, it has remote PowerShell enabled on it automatically. You can configure roles and install features. So you could, kick off a PowerShell script that deploys IaaS or ASP.NET, or if you're SharePoint, it could deploy AD, domain services. It could deploy whatever you want to do. You could actually download and configure WebPI and then install a WordPress server, right? There's nothing really that you can't script. If you're familiar with web roles and worker roles today, just think of this as startup tasks for virtual machines, which is the last point, download and execute other scripts or software. So I've written kind of a clunky demo. It's a PowerShell script that does exactly that. You put this little simple PowerShell script on a virtual machine, and it goes off to blob storage and downloads another PowerShell script and runs. And what that allows me to do is I can have multiple of these guys, multiple images, and I can configure them however I want. I can literally have a PowerShell script that installs WordPress, or a PowerShell script that installs SQL Server, et cetera, and I don't have to know about that ahead of time per virtual machine. I can change it on the fly. So let's show you that real quick. And the whole point of this demo is really to show you capture, but that's kind of boring, so I wanted to show you a bunch of PowerShell stuff too. So I'm going to flip over to the portal. And I have a virtual machine called Bootstrap VM already. Oh, sorry. Thank you. And I'll give you a real quick tour of what this PowerShell script does. Not going to go into it too detail because I'm actually going to post this on my blog later. So if any of you are interested in trying this out, specializing it, it should be there in a week or maybe a couple of days. Basically what I have is I put a zip file called config1.zip up in blob storage, and you can make this as many configs as you want. And I'm sure someone could write a service and make this even more customizable, but for now, I made it simple, config1.zip. And it basically, the first thing it does is it actually downloads this config1.zip. It unzips it, and it reads an XML file of what to do then. And the XML file got two commands in it. It has an execute command or an unzip. Really simple. It allows me to upload a zip file, unzip it, and then do something once it's unzipped. So if you take a look at what the manifest file actually looks like. Oops. This one right here just runs a batch file that enables PowerShell remoting. But I have another one, config2, that does all kinds of interesting things. This one is actually going to launch a PowerShell script that installs ASP.NET, IaaS, enables web service, enables remote PowerShell, deploys WebPI, and WordPress, all in one script. Kind of nice when you boot it up, if you want a WordPress VM, that is. Of course, you could do SQL Express or whatever, anything else you wanted to do. And the whole point of this is to show you how to use a startup script. So I'm going to take this script. I'm going to put it on the root drive of this VM. And one thing I need to do, since this is a PowerShell script, is I need to, and like I said before, everything is locked down. I need to enable PowerShell. So I need to set the execution policy. That way I can execute a PS1 script if I want to. And while that's thinking, I'm going to set up the startup script. So to enable a startup script on Windows, I know this is way basic, but most people really don't know it. I didn't know it until about 3 weeks ago. You go to Add Remote Snap-in, and under Group Policy, and I'm sure there's tons of AD administrators that'll watch this session later and say, he didn't know that, but that's okay. Azure people are mostly developers, so we can get away with this. Under Windows settings, there is a script setting. So you can have a startup and a shutdown task. So you can just imagine if you can have a script that launches on startup, how much fun you could have with a script that launches on shutdown as well. So I'm going to go ahead and add a script, and it's going to be a PowerShell script. So the next time this virtual machine boots, it will run PowerShell bootstrap.ps1. And I want to make this an image, so I want this to happen every time I create a new virtual machine, not just once. So to do that, I'm going to run sysprep. And this is everything you need to know to create a virtual machine image in Windows Azure. I need to leave it as inner system out-of-box experience, select generalize, shut down, and wait about 5 to 10 minutes for it to actually do all its uniqueness stuff and shut the virtual machine down. So I can literally go away from this machine, and how you'll know it's done is back in a portal, here where it says running, it'll actually be in the shutdown state. As soon as this prep has done everything it needs to do, it'll be shut down, and you can go into this virtual machine, and this button right here, capture, will be lit up. You can click capture, and you actually have just created yourself a custom virtual machine image. So remind me if I don't come back to this, and once it's all shut down, we'll finish the capture process and go back to it. Now, what it looks like whenever you boot up is I actually have a couple of these images already. I have 3 custom images. I have Bootstrap Config 1 and Bootstrap Config 2 and Web App Image. Web App Image is, I don't even remember what I have on that one, but I'm sure it's really creative. But Bootstrap Config 2 downloads the config2.zip, and Config 1 downloads config 1. So if I wanted to use this script, all I really have to do is create a new virtual machine from gallery, and instead of selecting platform images, I'm going to select my images. You'll see all the custom ones we just built. Oops. And give it a unique name and which data center you want to create the virtual machine in. And now about 30 to 40 minutes from now, this machine will boot up, fully configured with IaaS and WordPress and PowerShell enabled. So now that we've talked a lot about automation, I'm sure everyone is going to go back and automate their entire IaaS environment. You can do all the PowerShell stuff, all the configuration stuff you just saw also works with your cloud services as well. So you know how to configure both. I want to talk a little bit about availability sets and load balancer. So does everyone remember availability sets? Yeah, okay. No one ever remembers availability sets because they're really bizarre. They're very specific to running your stuff in an automated data center. Because in your data center, you don't have these because you have to do this manually. Whenever you create 2 virtual machines of the same type, say 2 web servers or 2 SQL servers or whatever, anything that does the same job in a multi-node environment, you want to put them in an availability set. And the reason why is Windows Azure, or the Fabric controller, reads this sets and says, okay, so SQL 1 and SQL 2 are together. I'm going to put them on 2 separate physical racks in a data center. And the reason is, if we lose an entire rack, SQL 1 is still serving requests, so your mirror is still up. So it gives you a much higher level of availability in the data center. The second thing it does is we're all hosting all these virtual machines on Hyper-V. Hyper-V runs on Windows. Windows requires patching. So whenever the Windows Azure, we go back and we actually patch the virtual machines, or the machines running your virtual machines, we have to reboot your servers every now and then. And we do that by order and availability sets. So if you have 2 virtual machines in the availability set, we say we're only going to bounce 1 at a time. That way your application is never down all the way. And this is the only way you can get a 99.95% SLA in cloud services or virtual machines. The second thing I want to talk about is load balance sets. Load balance sets, exactly what it sounds like, 2 virtual machines that's going to distribute traffic over a specific port, say port 80, port 5000, it doesn't really matter. We support TCP and UDP, so you can pretty much load balance any service you want. How you put these 2 together to make a very available system is, this is a really simple example, but at the, say we have a database set that's mirroring, or it's using always on, we'd want to put these 2 in an availability set, so if SQL A dies, we still have SQL B. Want to do the same thing with the web server, so we'd have a SQL AV set and an IaaS AV set. And of course, from a scale perspective, in this situation, we would actually be using the public the front-end load balancer to distribute traffic between the websites. So what if we want to do a little bit more availability at the load balancer level? Say your application answering port 80 isn't enough. What if we actually want to know if the application is up and running, it's happy, it can talk to the database, it can talk to some SAP server back on-prem. Just answering yes or no is not usually good enough for websites, because websites just do everything. They talk to all kinds of services. So you can extend the load balancer via custom probes. And how this works is our load balancer actually polls your website every 15 seconds. If it receives, whenever you configure custom probes, this is, by default, if you just configure an endpoint in a portal, none of this happens. But using custom probes, if the website returns back anything other than a 200, like 500 for instance, the load balancer will automatically take that node out of the load balancer. It does continue pulling, though. That way, if your virtual machine ever actually does recover, something happened, I mean, you might actually use this as a way of removing virtual machines to update them manually if you wanted to. It does recover. So let me show you how you can actually configure health probes using load balancer. And of course, the only way you can do this right now is through PowerShell. You can't do this through the portal yet. So I have two virtual machines, IaaS VM1 farm, IaaS VM2. If I look at this application, it's a real simple app that I've already deployed. If I look at this app, you can see that I'm actually writing out the machine name it's actually been served from. So this is IaaS VM1 farm. If I hit enough times, you'll see IaaS VM2 farm. So pretty simple. We have a load balance, two VMs running IaaS being load balanced. What I want to do is show how you can actually enable this load balancer probe to kick one out if it gets broken. And how I can do that is by first configuring a load balance probe. And let me show you how to do that. It's actually already configured because it does take about 10 minutes to update, or 5 minutes. The first thing I'd have to do if I wanted to set this is to use the Add Azure endpoint. And there's 3 additional parameters I can specify. I can specify a probe path, which is a relative path of your application, home/health check, and the port. So even if your application isn't listening on port 80, you can actually configure this to actually go talk to any service on that virtual machine to report whether it's healthy or not. So I'm going to go ahead and create this application. I'm going to show you how to do that with the health probe. So this is the same application. It's real simple, literally just an ASP.NET site that pops up and tells you what machine it's running on. And I'm going to add 3 things. I'm actually going to add one major thing. I'm going to add a new view, call it health check. Into my home controller, a real simple test. This isn't a true health mon. In a true health check, you'd actually go off and check SQL and check all your connections and all that good stuff. In this one, I'm actually just checking to see if the current machine name is in my app settings in my web config. That way I can cheat and show how it works. So I do need to actually add that active server settings in my web config. Okay, so you can see I added all 3 machine names, the 2 servers in the farm and the one locally. That way I can still debug it without it dying on me. And I'm going to go ahead and deploy this up to the cloud. And if you're wondering how I did this, I actually deployed web deploy on my 2 VMs, and I have a job that synchronizes content between the 2. I know it's old school. If you're using Windows Azure websites, you don't have to do any of that stuff, but this is IaaS. You have to do some work again. So the application is now deployed. It does synchronize every minute or so, so it might take a few minutes for that change to go over. So what we can do, let's log into IaaS VM1 and see how that probe is actually working. So if I look at my web logs, if I scroll all the way down, you can see the load balancer. I don't know if everyone can see that. I think they can. You can see the load balancer is coming across with load balancer agent, and there's a 200. That means I respond back 200. Everything's hunky-dory. Load balancer says keep it in. So what I want to do is I want to actually break this. So I'm going to go into my web config, and I'm going to take out IaaS VM1 farm, and I'm only going to leave in IaaS VM2. So once this is synchronized, my health check, it's going to do something really silly. It's basically going to throw 500 exception, remove this node. And that will in turn return a 500 to the load balancer, and the load balancer will in turn take the node out. So now we have to wait for the content to synchronize first. So I'm going to look at my web config. It was updated 11/21, so it's not yet. So shortly, this is the only problem. This is, again, why you want to use Windows Azure Websites for deploying websites, if you can, because it does all kinds of stuff automated. OK, so it looks like our web config has been updated. So if I look down, I now only see active servers as ISVM2 farm. Should be good to go. So now we have to wait for the load balancer to actually poll. So it polls every 15 seconds by default. So there's a good chance we've been hit by now. So if I look down, sure enough, I now have a 500 error from that load balancer. So you can see the space 500 there. So now in theory, load balancer should have pulled the node out, or it should be within the next 15 to 30 seconds. So I should hit F5 again, and I should only see ISVM2 farm now. And now if I actually go fix my web config, ISVM1 farm will show up in about a minute again. So a nice extra additional check that you can do. You could write a bunch of really smart logic, go ensure do transactions, ensure that a customer can check out, ensure that their cache server can be hit, not just the dumb, hey, it didn't, I got a response, which is how the default load balancer is. I want to show one more thing. This is a pretty interesting scenario. You can do the same thing on TCP. It doesn't have to be HTTP. So say I had a product catalog, say an e-commerce site, and I had a product catalog that I really needed to scale this product catalog across multiple servers, and for some reason it wouldn't work in Windows Azure SQL Database. Maybe I need full text search, which unfortunately doesn't work yet. So just like HTTP, we can have it poll every 15 seconds, except this time it's on a socket, so there is no HTTP response. What it does is instead it waits for an ACK on a socket. So as long as it gets an acknowledgement, the server's happy, life is good. However, if it doesn't get an acknowledgement, the traffic to that node is completely shut off, just like we saw with the web server. But it does continue polling, and as soon as you get an acknowledgement back, it will actually put the SQL server back in rotation. So let me show you real quick how you can do the same thing we just saw with HTTP with TCP. So literally the same type of code. The only difference is at the very end. Yeah, we're specifying the protocol as TCP instead of HTTP. Oh, sorry. I'm going to remember that. So at the very end, I'm specifying the probe protocol as TCP and a probe port, and I don't have a probe path. There's not a /home/health check, so that's really all there is to it. And you update the virtual machines, and everything's pretty good to go. So I have an application I can show you how this works. So as you can see in my connection string, there it is. Pretty small, so I'll zoom in. The connection string, I'm pointing to one domain name, or one DNS name. It's a public cloud server sub my SQL server. And if I go over to my SQL Server VMs, you can see on my endpoints, my VMs, I have a load balanced endpoint on 1433. So the same concept, except it's really just a different port. Now what I can do, let me create a Windows Azure website just to show you how that will work. I already have one running. Let me go ahead and just walk through. So I'm going to put this in West US. And this is not running in a VM. This is actually running separately in Windows Azure websites. How many of you have created a Windows Azure website so far? A few? OK. So I've already created the website. And all I have to do to set up publishing for it, you don't have to go to the command line. It's actually quite a bit simpler, is I click Download Publishing Profile. And I can save this. And now when I want to take my website and actually publish it up to that website, I hit Publish, Import, and it's packaging up my ASP.NET application and publishing it up to Windows Azure websites. Okay, so this is the exact same. This is an Azure Store application, and it's load balanced against 2 SQL servers. Now, I do want to show how that actually is distributed. You do have to generate a decent amount of load for websites to actually start load balancing across multiple instances. But right now I have it on free. If I really have a product catalog that needs multiple SQL servers, read-only, it's probably going to be pretty high scale. So to do that, I'm going to flip it over to reserved, which means I'm not sharing my website on anyone else's. I'm going to get a dedicated virtual machine. I could put this on medium, or I could get a bunch of quad-core machines. I don't remember how much my quote is. I'm going to stick with small and keep it at 3.